Right. Good morning, guys. I am Joseph, and I was the lead and the cloud architect for this project. So my job was to manage the AWS infrastructure, yeah, and everything, EC2, IAM, RDS, ALB, and the AMIs too. Good. So from this, let's start from this diagram. You can see that system use a three-tier architecture, so ensuring availability, security, and scalability. So you can see the CloudWatch, the IAM, the AOBs, the front end, and we have two S3 buckets. The front end, that's hosting the static website, and the private S3 buckets, that's it will host that it will store uploads. Yeah. We also have the RDS on port 3306. You have the EC2 instance, two EC2 instances. So we have the first one and the AMIs. Yeah, the AMIs too is there. Good. So we also have the AOB on either HTTP or HTTPS. That's port 80 and port 443. All right. So let's go into the EC2. So I just created a command out to just make me log into the EC2. So EC2, we have the backend and the database inside the backend. So you can see the backend. Good. And here you can see our env file. So the server.js is our API, our env, and our database. So to make this server.js alive, we use pm2. Good. So pm2 status, you can see that it's there. So our name is forensic API and it's online. Good. So that's for the EC2. All right, so let's go into the AWS structure. So let's go into the S3. Let me show you the S3. After that, we'll go into the EC2. I'll show you the security groups and the rest. Okay, so this is the public one hosting our website. Sorry, the front end. So you can see the app.js is our API connecting the front end to the back end. You can see our HTML and CSS. So this private bucket, there's nothing inside because we haven't uploaded anything yet. But it works. I uploaded and I deleted some files. Alright, so that's it for the AWS. Let's go into the EC2. So you can see that we have two instances. So our EC2, we used the T3 micro. Good. So this one is the AMI. The AMIs. This one is the AMI, and this is the main instance. Good. So you can see. All right. So let's go to target groups too. So this is our target group for the EC2 for the load balancer. Let's check the load balancers too out. Good. So this is our application load balancer, and we have one AMI here. Good. The backend AMIs, security groups. So good. We have the one for the ALB. So it allows HTTP and HTTPS to the load balancer. The RDS2 allows MySQL from the EC2, only from the EC2. And the EC2, it allows ALB, traffic from the ALB, and SSH. Good. That is it for EC2. So let's go to RDS. So let's go to IAM. Let's go to IAM. So you can see the users over there. You have roles, policies. So I created this role, and we also have policies. And these are our users, IAM users. Good. So you can see the IAM users over there. Good. All right, let's go to the. We are done with the S3, EC2, and IAM. Let's check the RDS. RDS. All right. Okay, so you can see our database. Good. So forensic database available. We use my SQL. Good. So this is our database. All right. Let's go to the CloudWatch where everything is being monitored. So the CloudWatch actually, when everything goes sideways, I will receive a mail that this is happening to the CloudWatch. So go check it out. All right. So you can see everything over here. Alright, so this is the CloudWatch. You can see everything is working perfectly good. Alright, so this was basically my job, managing the AWS infrastructure, the EC2, IAM, and everything that's in it. Thank you very much.
My name is Jerry, and I work as the front-end developer of our group's project. So, without wasting much time, let me take you through it. So, as you can see over here, this is our login where you can sign up to the website. So, I've already signed up already. Okay. So, you can see, so here you see the dashboard, the cases, and evidence. The report, since we haven't uploaded anything there, so since we haven't uploaded anything there, you can see that it shows over here that the total case, that means there is no case, we haven't opened any case, and there is no evidence as well. Yes, so this is all you have to know about the website. So I'll take you to where the website is hosted. So it's hosted in our cloud, as you can see over here. So AWS, yes. So this is where we posted. This is where we posted the website. Yeah, so as you can see, the website has been posted over here. Yes. Okay. Also, let me tell you something small. So my main responsibility was to develop the user interface. So this is our website. So I was to develop the user interface of the application. I used HTML for the creation of the structure of it, as you can see, and the designing and the styling I used CSS. So as you can see over here, so my role was to make sure this information was presentable through a clear organization and user friendly interface using HTML, CSS, and JavaScript. Yes. My name is Jerry Neokosi. Thank you.
Hello, my name is Emmanuel Nanajan Asari. And on this project, I worked as the backend developer. As the backend developer, I was responsible for the architecture, security, and maintenance of the API layer and the relational database connection. First, let's look at the .env file. Our .env file handles our environment setting. It keeps credentials secure by holding database connection keys, the JWT, secret AWS S3 and CloudWatch settings, and strict calls configurations. Second, our package.json manages our dependencies. It also imports expresses for the server's standard security tooling like the helmet and the rate limit, and also authenticates the AWS SDK for cloud features. Our server.js file is the main entry point, which talks about our routes such as the authentication, evidence tracking, and audit logs. It also handles global security middleware, logging, and grateful shutdowns. As the backend developer on this project, my focus is delivering a secure complement system by building the core API logic for evidence tracking, user management, and also authentications. Also, it is my duty to maintain database integrity by using the Amazon RDS MySQL to ensure strict chain of custody logging. Server.js acts as an entry point and expresses server configuration. It actually initializes the node.js HTTP server and mounts security middleware. It contains some components such as the middleware setup, the routing engine which directs the API to specific route controllers, and error and event handling. As the backend developer on this project, I worked on the API route implementation and business logic, building endpoints to handle authentication and other stuff like auditing, logging, and user management. I also secured endpoint route using the JWT validation and enforcing strict rate limiting on sensitive endpoints like login and authentications. Also, I worked on the database management, designing schemas and executing queries against the Amazon RDS. I also made sure that I maintain database transactions to guarantee straight and legal. Once again, my name is Emmanuel Nanajan Asari, and I worked as the back-end developer on this project. Thank you.
So hello, my name is Leslie, and in this project, I was responsible for the database and the cloud monitoring components. So these are the critical parts of any cloud application because they ensure that the data is stored securely and that the system's performance is continuously tracked. So for the first image or proof, that we are in the database proofs. So the first image 2.3, our RDS MySQL database. So it is proof of the managed relational database showing available status. So this is our Amazon RDS MySQL database, which we created under the AWS free tier. You can see that here the database status is available, the green tick. Yes, you can see status available. So it means that it is running and it is ready to handle our requests. So the database stores all user and case information for our digital forensic systems. Okay, that's a forensics database. And so then the next one, we move on to image 4.1, which is application verification, the back-end health check, and the PM2. So a proof that the Node.js backend is running and the database connection is healthy. So let me try zooming in. Okay, so here you can see that the backend health check response. Yes, so you can notice that the line that says the database connected, the bottom of the screen, the last line over here, status healthy, timestamp, yes, so database connected. That's to prove it. So this proves that our application is successfully connects to the RDS database, allowing us to perform our CRUD, our create, read, update, and delete operations securely. Okay then, so on to our next image. We'll be moving to our cloud monitoring section, the cloud monitoring parts. The first image will be image 5.1. Okay, our CloudWatch dashboard. So a proof of custom metrics monitoring EC2 CPU/network and RDS connections. So this is our CloudWatch dashboard we've set up. Its main use is to track key metrics such as the CPU utilization, as you can see, the network traffic, where it has been labeled as network in, network out, and then our database connections, as you can see over the database connections. So monitoring these values help us to understand how the system is performing and to detect any unusual activity. Okay, so the final one, image 5.2, our CloudWatch alarms. It's a proof of automated alerts configured for high CPU utilization. So as you can see, we've configured the alarm, the CloudWatch alarm, and so this alarm triggers if the CPU utilization goes above 80% for the first 5 minutes. So it is going to ensure that we are alerted to potential performance issues before they affect the users. So this is basically it, my proof for database setup. So in summary, my role was to ensure that our application had a reliable database and a strong monitoring system. So these components guarantee that data is stored securely and that the system remains stable under load. So together they demonstrate AWS best practices for building cloud native applications. Thank you.
So good day everyone. So my name is Emmanuel J, and I am the quality assurance specialist and security member of Group 17. Our project is the cyber security digital forensics evidence management system. So my responsibility for this project was to make sure the system was secure, properly authenticated, tested, and monitored. So I tested authentication, API responses, database operations, and security behavior to make sure the system works perfectly. And also, another part of my responsibility was to monitor the system using the Amazon CloudWatch. As you can see here, there is the EC2, S3, CloudWatch, and then the IAM user thing. So in conclusion, my role as a quality assurance specialist and security member was to help ensure that the system was secure, reliable, and functioning correctly. My main contribution were the AWS security configuration, authentication, and testing, API testing, access control, and CloudWatch monitoring. Through the test and security control, we were able to verify the reliability and security of our digital forensics management evidence management system. Thank you for watching.